Students, today class discuss about graphical representation of motion. In a previous video, you know the important definitions: speed, velocity, acceleration, and equations of linear motion. V equal to u plus at, s equal to ut plus half at square, v square equal to u square plus 2as. In a given certain value, how to calculate the acceleration, displacement, time using equations of linear motion. So today class, graphical representation of a motion. The position of a body change with time. Any body moving along the straight line. So motion means the change in position of a body with respect to surrounding with a time. The position of a body change with the time. And also velocity, acceleration also vary with time. So position, velocity, acceleration vary with time. These variations can be shown graphically. There are three important graphs are there: position time graph, velocity time graph, acceleration time graph. Now first graph is a position time graph. Position time graph, or simply you say that xt graph. X is a position, t is a time. Students, the first graph, position time graph. So simply we say xt graph. X is a position, t is a time. Now example here, a body moving along a straight line. A body moving on the road, or a vehicle moving on the road. Where to where? Example here, A to B. So A to B. Now x is a distance or position. T is a time. So after 2 seconds, the body starting at A. So after 2 seconds, the body covering may be 10 meter. So x equal to 10 meter. And time t equals 2 seconds. The body starting at A. So after 2 seconds, how much the body covering? Maybe 10 meter. Okay. So after 4 seconds, maybe 20 meter. 6 seconds, so 30 meter. So after 8 seconds, maybe 40 meter. So next 10 seconds, so 50 meter. So I give an example here, a vehicle or a body moving along straight line. Example, a vehicle moving on the road. Now 2 points are there, A to B. Now initially the body moving the starting point A. After 2 seconds, so how much distance must be covered? X equal to 10 meter. After 4 seconds, 20 meter. After 6 seconds, 30 meter. After 8 seconds, 40 meter. So 10 seconds, 50 meter. Now you record time and position. Now you plot the graph. So graph means 2 axes. Here this axis. Now we have this x axis. Here x axis. Now this is y axis. So position, the distance where x value taken along where? Along y axis. X value. Position along the y axis. And time t along x axis. The graph obtained by plotting position along the y axis, time along the x axis. This graph is called a position time graph. Now here time. So time here, yes, O. So here after 2 seconds. Now here 4 seconds. Now here what? Time 6 seconds. Next what? 8 seconds. Next 10 seconds. The time taken along the x-axis. Now position taken along the y-axis. In y-axis what? X equal to here. Maybe here marking 10 meter. Now 20 meter. Here 30 meter. So 40 meter. 40 meter after 50 meter. 50 meter. Now here after 2 seconds, how much the body covering? So 10 meter. So here 2 seconds, how much here 10? So just mark the point. So after 4 seconds, so 20 meter. After 6, 30. So 40. So after 50. So you mark after 2 seconds, how much body covering? 10. 4, 20. 6 seconds, 30. 8 seconds, 40. Now join this line, so you get straight line. So this graph is called a position time graph. So what is a position graph? The graph obtained by plotting position along the y-axis and time along the x-axis. How to plot the graph? We first to take an example. A body or vehicle moving along the straight line. Example A to B. The vehicle starting at A. After 2 seconds, how much a body or object covering distance 10 meter. So 4 seconds 20 meter. 6 seconds 30 meter, like that. X means position taken along the y-axis. Time taken along the x-axis. Now here each unit 2 seconds, 4 seconds, 6 seconds, 8 seconds, 10 seconds along the x-axis. Y-axis 10 meter, 20 meter, 30 meter, 40, like that. So now mark the points here. Join these all points with straight line. This graph is called a position time graph. What is the position time graph? The graph obtained by plotting position along the y-axis and time along the x-axis. Now draw the triangle, right angle triangle. This is called slope. You draw the triangle. That is called slope. Draw the slope along the graph, straight line. Now mark the points. So here A, this is a B, here C. So A, B, C. So here A, B, which axis? Y-axis. Y-axis taken what? Position. The change in position symbol dx. The change in position, the symbol represent dx. The change in position of the body taken for time, so dt. Here A to B, AB is a, so axis, y-axis taken for position, so dx change in position. The change in position take for time t seconds, small interval of time, so dt, so cb equal to dt. Now slope equal to slope equal to AB by BC. Slope equal to what? AB by BC. On what basis? Tan theta. So tan theta definition. So here tan theta. So slope tan theta equal to AB by BC. So now AB what? dx. And BC equal to what? dt. So AB equal to what? dx. Dx is a change in position. The change in position take for time, a small time, dt. So dx by dt. Dx by dt is what? The rate of change of displacement. The rate of change of position of a body in a particular direction. So dx by dt is the rate of change of displacement or position, that is called velocity. So v equal to dx by dt. What does represent the slope of the xt graph? This is the one mark question. What does represent the slope of the position time graph? The slope of the graph gives what? Velocity of the body. So you get velocity for this formula. Slope equal to AB by BC. AB by BC. So AB is a change in position. The change in position of a body, how do you represent symbol dx? The change in position of a body time t second. So dt. So change in time dt. dx by dt is the rate of change of position of a body in a particular direction, or the rate of change of displacement is called velocity. So finally, the slope of the graph gives velocity of the body. This is one more question. What does represent the slope of the position time graph? So the slope of the position time graph represent velocity. The slope of the position time graph gives velocity of the body. So v equal to dx by dt. And sometime two more question. Draw the position time graph for a body at rest. So this graph. So this is x-axis, here y-axis. X-axis, the position taken along the what? Y-axis. Time taken along the x-axis. Now t, time along the x-axis, position x along the y-axis. For a body at rest, a body traveling certain distance, maybe 10 meter. So after the body do not covering. So 2 seconds, the body will be 10 meter. The body at rest here. So the body at rest after 2 seconds, how much distance will be covered? 10 meter. How you draw the for a body at rest this graph? So this is one more question. Draw the position graph for a body at rest. So this graph indicate the body at rest. Draw the position time graph. Uniform velocity. So uniform velocity means this graph. So after 2 seconds, maybe what? 10 meters is the same graph. So these two graphs are very important. Draw the position time graph for body at rest, uniform velocity. So uniform velocity this graph. Body at rest this graph. X here. So time. So this is the first graph. Position time graph gives the slope of the graph gives velocity of the body. So I repeat one more time. Position taken along the y-axis, time along the x-axis. This graph is known as position time graph. This graph gives the slope of the graph gives velocity of the body. Students, now second type of graph, velocity time graph, or shortly you call VT graph. VT graph, velocity time graph. So what is a velocity time graph? A body moving along straight line. So after 2 seconds, the body which maintain maybe 20 meter per second. So after 4 seconds, 40. So time increase, speed of the vehicle is also increased. So velocity taken along the y-axis, time taken along the x-axis is very important here. Velocity taken along the y-axis, time taken along the x-axis. The graph obtained by plotting velocity along the y-axis and time along the x-axis. This graph is known as velocity time graph or simply VT graph. VT graph represents velocity time graph. A body moving with a uniform acceleration, a uniform velocity. So you get straight line. Straight line. So after 2 seconds, maybe 20 meter per second, 4 seconds, 40 meter per second, 6 seconds, so here 60 meter per second, after 4, 80 meter per second. Now you get straight line. So once again draw the triangle, right angle triangle, that is called slope. So we mark the points A, B, C. So AB, which axis? Y axis. The change in velocity, symbol dV. The change in velocity takes for small time. So dt. So AB dV, change in velocity taken per time t second at dt. Now slope equal to AB by BC. So slope equal to AB. So AB by BC. Slope that is a tan theta. Opposite by adjacent side. So AB. So AB equal to what? dV. BC equal to what? dt. So you know the mathematical this formula in a previous video. dV by dt. dV by dt what? The rate of change of velocity is called acceleration. So small e. So now the slope of this graph gives what? Acceleration of the body. So now here one more question. What does represent the velocity time graph? What does represent the slope of the velocity time graph? The slope of the velocity time graph gives acceleration of the body. So this graph, the slope gives acceleration of the body. So I repeat one more time here. The slope equal to AB by BC. So AB, which axis? Y axis. So AB is the change in velocity. Change in velocity symbol dV. Change in velocity takes place time t second. A small time dt. Slope equal to AB by BC. So AB dV. So BC dt. The rate of change of velocity is called acceleration. Now the slope of the VT graph gives acceleration of the body. So this is one more question. What does represent the slope of the velocity time graph? Acceleration. And two more points here. What are the important applications of VT graph? Or what are the importance of this graph? So VT graph helps us to study the nature of the motion. Is a very important point here. Mention in a two applications or what are the importance of VT graph. So first one, study the nature of motion. Study the nature of motion. Example, you take one ball or stone. So you throw the ball. So what kind of shape? This is a parabola. This is a parabola. Velocity taken along the y-axis, time taken along the x-axis. Just you throw the one ball, the ball goes this structure, this shape. This shape is a parabola. So parabola, hyperbola, and ellipse is the nature of the motion. This graph helps study the nature of motion. And second point, this graph gives to find the what? Acceleration of the body. So acceleration of the body, second point. And third point, this graph helps us to find the instantaneous velocity. Instantaneous velocity, the value of velocity at any instant of time is called instantaneous velocity. The velocity at a particular instant of time is called instantaneous velocity. At what time velocity is there, that value is represented instantaneous. So this graph is used to find the instantaneous velocity. And fourth one, this graph is used to find the displacement of the body. So here 4 points are there. The first point, this graph helps us study the nature of motion. For example, here parabola. This graph helps to find the acceleration of the body. This graph is used to find the instantaneous velocity. This graph is used to find the displacement of the body. So what is a VT graph? What are the importance? The graph obtained by plotting velocity along the y-axis, time along the x-axis, the slope of the body which gives acceleration of the body. Friends, third graph, acceleration time graph or simply AT graph. AT graph or acceleration time graph. What is an AT graph? The graph obtained by plotting acceleration along the y-axis, time along the x-axis. So the acceleration you have taken, the value taken along which axis? Y-axis. Time is always x-axis. The graph obtained by plotting acceleration along the y-axis, time along the x-axis. How to calculate acceleration? Acceleration equal to change in velocity by time. A equal to b minus u by d. So A, acceleration taken along the y-axis, time taken along the x-axis. Now you get graph. So this is the graph. Acceleration is positive if the velocity of the body increase. Example, aeroplane, take up. Velocity increase, acceleration is also increased. What does represent the slope of the acceleration time graph? Change in velocity. So airplane take up. So what? So velocity may be increased. Acceleration is also increased. So when is acceleration is change in velocity. And one more graph here. So acceleration taken along the y-axis, time along the x-axis. So you get negative acceleration. So acceleration will be negative if the velocity of the body decrease. If the velocity of the body decrease. So the negative acceleration is called a retardation. So what does represent the slope of the acceleration time graph? Change in velocity. Change in velocity. So this point is very important, students. What does represent acceleration time graph? So acceleration time graph. So this is a straight line. Acceleration is positive if the velocity of the body increase. So velocity will be changed. Acceleration is also increased. So acceleration is positive if the velocity of the body increase. So this graph gives change in velocity of the body. So now three graphs are there. What does represent position time graph of this slope? In position time graph, velocity of the body. Velocity time graph, acceleration of the body. Now here, acceleration time graph, change in velocity. Change in velocity, acceleration time graph, the slope gives change in velocity.